There's one subject that I want to talk about that is very important when it comes to rigging, and is joint orientation. And this is something that not only applies to joints, but to any hierarchy that you're going to be using in Modo. But we're going to be looking at it in the context of joints because that's something we're going to be using a lot during the course of rigging. And there are certain things about joints in Modo that you need to be aware of. So let's take a look at that. I'm going to hide the cabinet and the lamp and just unhide this joints group that I've created. And it has a little joint chain over here. So if I select all the joints in the chain, you will see that you get all the centers displayed, which is something that you get a lot in Modo. If you're familiar with rigging in other applications, you will probably have heard about the terms joint or bone being used. And there is a difference between joints and bones, depending on which application you see those. A joint, it's just basically a point with a transform. It's a point in space. It's a location. There's nothing else to it. And you can take this point and move it around, and that's pretty much it. It's a very simple hierarchy. And this has its advantages and disadvantages like everything else. The thing with bones, if you've seen bones in other applications, is that a bone, it's an actual object that has certain properties related to bones, such as bone length and things like those. In Modo, we don't have bones, we have joints, and they're basically just locators in a hierarchy with certain display properties being used so that they actually draw in this particular way. But you could also just create a bunch of locators, parent them any way you want, and you could have a bone chain right there. So there's nothing different about that. But let's go back to talking about these guys. When you draw a bone chain in Modo, well, a joint chain, sorry, I might use the term bone or joint sometimes interchangeably, but we're referring to joints. One thing that you will notice is that all the rotations for the joints are zeroed. And if you remember when we talked about parent space, you would say, okay, if I know that the parent space for a given object is its parent, and both the object and its parent are not exactly at the same point in space and oriented the same way, then there should be a difference in the transforms. And over here it's not the case. There is one with position. You can see that there's a distance between the parent and the joint that we have selected, and this would actually be, if you want to see it that way, your bone length for the parent, of course, because that's the distance between him and the parent. So that's this length over here. But when it comes to rotation, there's nothing, and it's very clear that both the parent and the selected joint do not have the same rotation. Otherwise, this guy would be pointing, well, this way. So what's going on in there? Well, what's going on is when you draw a skeleton chain, Modo figures that you're drawing it in what it's going to be known as its rest pose or setup pose or whatever you want to call it. So that's going to be your reference pose, your zero pose, your go back to neutral pose for the character, for its joints. So it zeroes everything for you. So you can easily go back to that rest pose. If I take this guy, oops, I have on, hold on, I have on child compensate. Okay, let's turn that off. If I rotate this guy, it's the character's arm, you will see the rotation value here. If you want to go back to the neutral pose for the character, you basically just zero everything, and he goes back to this neutral position. But it is clear that it's not a position where you would have 0 degrees difference between this joint over here and its parent. So what's going on is that when you create joint chains, Modo actually adds secondary transform for rotations on the joint. So the primary will be zeroed, and the secondary will actually store the proper values when it comes to the orientation of this object in relation to its parent space. So you can see that we have a 33-degree rotation on x, which is this axis over here, which gives us this little bent angle, and we have a 180-degree rotation in z, and you will see why in a second. So this is important to know, because if you don't deal with this when we're talking about joint orientation later, you're gonna have a lot of headaches to deal with, and you're gonna lose a lot of time fixing stuff. I'm gonna show you why. But before we do that, I'm gonna show you how to change the rest position or the setup or orientation of joints properly. If I take this guy, let's say that you want the elbow slightly bent towards the back, right? If I take this guy and I turn on child compensate to not disturb the other joints, and I move him back, two things will happen. You will see that the joint is now misaligned in terms of its child over here. It's no longer pointing towards it. And the same thing has happened to its parent. It's not longer aligned with the joint I selected. So I misaligned the joints, which is something you want to avoid at all times. You want to have joint chains that are always properly aligned. So to do this, you don't use the actual transform tools. What you do is you select the entire chain that you want to modify, and you turn on the skeleton tool, and you will get these blue dots along the selected hierarchy. And using these, you can just start to move the joints to wherever you want, and as you can see, they're automatically realigning to be pointing towards their child at all times. So this allows you to change the orientation of a joint chain without disturbing the alignment of the joints, okay, which is what you want. So try to use the skeleton tool whenever appropriate. And you have to be aware that the skeleton tool only affects the joints that are selected. So if I turn on these, or even just this guy, and I turn on the skeleton tool and I move him, you will see that the parent is now misaligned again, because he's not under the influence of the skeleton tool, so he cannot reorient. Okay, so just something to be aware of. So I'm going to leave it like that. Let's say that you accidentally, for some reason, misaligned one of the joints, or you want a different alignment. We have a very useful tool for that in Modo, which is the Align tool. And this tool will allow you to realign the joints in any way, so that you can have custom orientations, or you can fix misalignments. So if I just take it and leave the options that I have right now and hit OK, you will see that now everybody's pointing towards their child, which is what we want. And obviously, of course, the last joint in the chain, since it has no child, well, it's just going to be using world orientation. It's going to be aligned towards like the world, so it remains at 0, 0, 0 in rotation. Its channels are zeroed. So one thing that you will want to do is, when you're fixing orientations or changing them, the first thing we want to do is we want to deal with the actual rotations that the joint has. We don't want to deal with the zeroed ones. And actually, now that I use the Align tool, you will see that I threw the zero rotations totally off. And the reason is, well, the Align tool changed all the axes, so now I have different rotations. But I also have the original ones that were stored on the secondary transform. So we definitely are running into a little bit of a mess here. So what we want to do is we want to deal with a single set of values when it comes to our transforms with joints. And we're going to be fixing these guys so that we deal with a single set. The way to do that is we're going to select first the secondary transform and shift select the primary, which is the one in bold text, and then we're going to say merge. So what this does is it takes all the values for all the selected transforms that I have. I could have more, they just have to be of the same type, in this case rotation, and it adds them up and stores them in the last selected transform. So in this case I have now everything stored properly in this rotation transform over here, and I can take this one and say delete. Just right click on it and delete it. So we don't need it anymore. So now we're dealing with a single set of transforms, and the primary transform is the one that gets at all times displayed here in the properties panel. Okay, so let's take now this guy and fix him the same way. We take this and this, we merge them, and now we take this guy and delete him. So now we know which angles we're actually dealing with when it comes to this joint. Let's do the same for him. This guy and this guy, merge this guy, delete, and we'll do the same with him. Him we actually don't care too much about because he's the last in the chain, and we're actually gonna delete him, but just for cleanliness sake, we're gonna fix him. So now we have our proper transforms over here. The nice thing is, if I wanted to actually have this guy point exactly at his parent, all I have to do is 0 the rotations and oh sorry, not 0 them, reset them, and now he's pointing exactly the same way as his parent because I've made sure that there's no rotation difference between both. But let's go back to looking at the orientations of the joints. So now that I have actual values in there to reference, I want to fix one particular problem. It is a problem of having, as you can see, the first joint in the chain is facing, it's flipped 180 degrees with relation to its the rest of the chain. These guys have X facing forward and Y facing to one side, and then this guy has X facing backwards and Y facing the other way. So he's flipped 180 degrees with relation to this other orientation. So there's several ways to try to fix this. First, we can use the align tool, and again, you can use many options in here. First, we determine what we're aligning, if the center or the pivot. We're definitely interested in the center. And then you have the direction and the axis orientation parameter. The direction is going to be the axis running down the length of the if this was a bone, the length of the bone, right? Or the axis looking at or pointing towards the next child in the hierarchy. And then this axis is going to be your secondary axis. It's kind of like the way the up vector would be pointing towards if there was an up vector here to look at. That's mostly for reference. I'll show you what that does in a second. When it comes to determining which direction you want to use, which axis you want to use for your direction, if you are rigging or creating a joint chain that you're going to be using just within Modo, then it's pretty much up to you to decide which directions you want to use. We're going to talk about order of rotations in a later video, but it has to do with this. So there are certain things to consider, but there's not going to be anything basically that you have to worry about. However, if you plan on exporting your character onto a different application, then you definitely have to check in that application which is the way that joints or bones are normally oriented, so you can orient them here in the same way. Certain applications, and this is especially true with game engines, for example, have particular requirements or defaults around how joints are oriented over there. So you definitely want to use the same one. Otherwise, when it comes to applying animations and copying and pasting motion and stuff like that, you're going to have a big mess that it's not going to work. So check with your target application before selecting the actual alignment of your joints in Modo. Otherwise, as I said, if you're just going to use it for yourself, then there's no problem. So let's keep this at ZY, and let's the default is usually seen as the up axis, and if I hit OK, well, this is what I get. So what I need to do is realign this guy, but let's check first. What if I use, for example, ZX? Then you will see that Z is pointing down and X is pointing sideways on these joints. Okay, this guy still flipped. So you get to decide which is going to be the axis that points sideways. And this has to do a lot with how the actual chain is going to rotate. Like if this was, for example, an arm, I might say, okay, you know what, my arm is going to be moving mostly like this and moving mostly like this, right? And a bit like this. But I would say that maybe this movement is going to be the least frequent one. The primary would be, for example, this one and this one, okay? So those are Y and X. We're going to worry about that when it comes to order of rotations. But for now, let's just say that we haven't identified that. So I'm going to leave it at ZY. Actually, ZX is fine. But I'm going to play around with the up axis parameters. So if I go to X, you will see that now all my joints are facing the correct way. And this is something you will need to experiment with, because depending on which orientation you're actually using, the up axis to use is going to change. So you might want to give them a try. And in some cases, they might actually not work. Like if I choose Y, for example, now I have Y pointing forward, but these guys are flipped. X is pointing inwards with respect to this guy. So you might want to give them a try. Now I use Z, and now everybody's pointing perfectly. With orientations, you might get unexpected results. So I'm going to show you another way of fixing this manually. So let's say that no matter what you try, this guy never came to alignment in relation to its children. Well, there's something very simple you can do. Since he's a parent of the chain, what I can do is just rotate him into place. So I'm gonna have to rotate him 180 degrees on Z to have him point the right way. But we have to do that while using child compensation, so I don't disturb the other joints down the hierarchy. So let's just rotate him 180 degrees. So there you go. And now he's pointing the same way as the rest of the joints. And if I check this child, I will see there's not anymore a 180 degree value over here, because that meant he was flipped with relation to his parent. Now we have only the actual angle that we have between both joints, which is what we want. So that's why we had to get rid of the other rotation channels, because then we would not be able to really know which values we're dealing with, and it's something that you really want to have handy when rigging. We're not really going to be animating joints directly. You will see why as we move along the course, but we definitely want to know which values we have in our joints. And this guy slightly rotated, we can just zero that and he's fine. This guy, he's good, he has a 90 degree rotation. Let's say that, for example, you're done with alignment over here. You say, okay, since this is an arm, I really don't need this joint anymore. I'm good. And then later you discover that, wow, oh, yeah, I didn't position the elbow correctly. So if I go and select this, or you need to realign for some reason, and you throw out of alignment other joints, let's try that. Let's move this guy more like that. You say, this is my new rest position, and now everything is misaligned. Here's something that it's going to be funny. You cannot use the align tool right away, because then this guy is going to go to 0, 0, 0 in rotation, and it's going to be facing the world. It's not going to be facing its parent. So what we need to do, like let's say I do that right now, you get this guy aligned, this guy aligned, this guy not aligned. So what we need to do is we'll get him a child so that he can properly align. So let's create a new locator, and I'm gonna set my drop action to match so that I can actually match him to something. And I'm gonna match him not to him, because that's gonna be this is the misaligned reference, but to its parent. So I'm gonna match there, and then I'm gonna move this down in local space, and then I'm going to parent them together. Parent in place. There we go. Okay. And now I select everything and I use my align tool again. And now this guy is back facing the correct way. And now I can delete my locator. So that's the way to fix a joint chain properly. Now, since we use the align tool again, this guy is rotated out of orientation in relation to the rest of the chain, but you already know how to fix that. So let's not lose more time. So that's what I wanted to cover in this video. It's important to be aware of these things, and you're going to see us be working a lot with joint orientation as we move along the rig, just to make sure that everything is properly set up so we don't run into funky problems as we go down to animation. Because there are certain things that might not be apparent at the rigging stage, but animators are going to be dealing with, and you don't want to hear the animators complaining that their function curves are all screwed up. So we'll talk more about that along the course. In the meantime, let's move on. Okay, let's talk about one last topic that I need us to cover before we jump into starting to look into rigging a character, and that's order of rotations on objects. And it's a topic that is related to the one we just talked about, which is joint orientation. And we need to talk about it because knowing about this can be the difference between a rig that is easy and pleasurable to animate and a living nightmare. So I'm going to show you what this is all about when it comes to rigging. So I've selected one of the joints that we have here, and since we last used the skeleton tool, we had some extra transforms created, because using the skeleton tool to tweak the positions of your bones will recreate these secondary transforms. So just to save some time, I went ahead and I cleaned up everything, and I'm just gonna quickly align this because that's not it. There we go. Oh no, sorry about that. It's this one I want. Yeah, there we go. So that would be the default orientation for my joint chain that we've been working with. And let's talk about the order of rotations. So as you know, every object that is in 3D space, in order to be able to tell the software which way it's oriented, it needs to be able to rotate on 3 different axes. So we have the X, the Y, and the Z axes on each object. And by rotating these, you can orient any object in any particular way. However, one thing that we need to know is that any object can actually reach a given orientation by a number of ways. There's many ways that you can have an object rotate that it will finally deliver the same orientation. And I'm gonna quickly illustrate that to you. I'm gonna add a couple of cones to the scene and add another one. And let's move this guy over here. Oh, I added 3. Let's get rid of the last one. So we have these 2 guys, okay? And let's say I want them to be pointing towards the right. Well, one way to do that, it would be to take this guy and rotate him 90 degrees, right? So there he goes. Now he's pointing to the right. However, I could reach exactly the same orientation using a different rotation solution. So I could take, for example, this guy And first, rotate him 90 degrees like so, and then 90 degrees like so. So there you go. We have the same orientation. And actually, this is why this guy has Z pointing up, so we also need to rotate this guy 90 degrees this way. Oops. Snap. There you go. Now they do have the same orientation, except the values that they are reflecting as part of the rotations they did to get here are totally different. So for this guy, for example, we have minus 90 on X, 0 and 0 and Y and Z, whereas this guy is minus 90, 90, minus 90. So that's a totally different scenario, but the end result is the same. So order of rotations is something that is very similar to this. It dictates how the values are going to be stored in the rotation channels so that an object can reach a particular orientation. And this, of course, goes hand in hand with how it is aligned, how its center it's aligned. Because a center that has a different alignment than this one will give you a totally different set of rotations. So both things go hand in hand. Now, why is this important? Well, there's two reasons for it. One is, as you can see, Modo stores 3 different rotation channels. So when you decompose a rotation into 3 different axes like this is what's called a Euler rotation. And the advantage is from a user perspective, it's very easy to deal with rotations in the scene because you're dealing with one axis at a time and you're dealing with a given amount of degrees per axis. So you can just grab the axis you need and rotate it and you're done. However, Euler rotations tend to run into a phenomenon known as gimbal locking, and this is something that can create lots of problems for animators, and it can be somewhat mitigated to a certain extent by using the proper order of rotation. So I'm going to show you what that is about in 1 second. The second thing of why you want to store rotations we're going to look at once we start looking at function curves, which will we do in a second. Let's delete them and go back to our joint chain. Okay, so we have this joint chain right here, and let's say this is an actual arm for a character, and you say, okay, what kind of movement is this arm going to have? Well, for this particular joint, if we consider that this would be the shoulder, let's say that he would need to rotate mostly like this. That would be like its main movement. And then after that, he obviously needs to do this, which is also an important movement to perform. And lastly, well, yeah, he'll probably do some of this, but that's probably not going to happen as often as the other two. So you need to be able to prioritize your rotation order in order to determine which settings you need to use here. So we just said, okay, this guy needs to go X, then Y, then Z. Now, you can say, well, I mean, I can still rotate him this way and there's no problem. Well, actually, there is a problem. If we go back here and we turn off local and you have gimbal turned on, you're going to be able to see the gimbal tool over here that shows you the actual axes as they are being used internally, and if you're going to run into gimbal lock. And you are. In this default setting that we have right here, you can see that the Z-axis is almost parallel to the Y-axis. So he's getting pretty close, and once this reaches this axis, you're in gimbal lock. And that usually always happens at 90 degrees. So for example, since it's the X-axis that is getting us close to gimbal lock, I'm at 70 degrees right now. If I type in 90 degrees, then you get gimbal lock. What does that do? Well, let me show you. Let's undo that, and let's turn on again our rotation tool. And I'm going to bring up the curve editor so that you can more clearly see what's going on. Okay, so I'm going to key these channels, and then I'm going to move forward a few frames, and I'm going to start rotating the joint on the x-axis, and I want you to notice what's gonna happen here. Okay, let me frame this a little bit better. So as I start rotating backwards, you can see the function curve for the x-axis to go down. That's fine, that's perfect. And then as I move forward, I'll keep going, and then when I reach this point, actually, you know what? I need to go into local mode. Okay. As I reach the point where gimbal lock is, oops, what happened here? As you can see, the Z channel now has a curve on it, even though I never touched it. So what happened is, as you can see now, our channels have 180 degrees rotation on Z and Y, and my rotation channel, instead of kept going beyond 90 degrees, now it's going backwards. So you've flipped because you ran into gimbal lock. And this is a big problem. Why? Because if I go further ahead in time and I swing back my arm, now the flip is in the other direction. So these flips make it not only very problematic for the animators to manage the function curves, but also give you a very funky animation. As you can see, the arm is wobbling around because the Y and Z axes are being transformed. So, well, to make a long story short, this is far from ideal, and animators will curse at any rig that does this frequently. So how do we get rid of gimbal locking? Well, what we need to do is determine an order of rotations that will prevent this from happening as much as possible. So how does that work? Okay, let's go back to frame 0. Let's delete the animation on this guy. There you go. We're back to everything normal. My channels are fine. Cool. So we're going to change the order of rotations and see what that does. But before doing that, there's something I want to do to my object. If you see here, well, its orientation is not aligned to the world, so I'm always going to have a weird offset once I change the rotation order due to that. So to prevent that, and just for illustration purposes, because this is gonna happen anyway when we rig stuff, I'm gonna give this guy a parent. Okay, so I'm gonna create a locator, set my drop action to insert, and drag and drop him here. Oops, hold on, I had compensation turned on. There you go, that's better. So now with this guy, since he's parented to an object that is aligned exactly the same way, he's all zeroed out. Very nice. And let's now select the entire joint chain, and let's change the order of rotations to, if Z is going to be the angle that is going to be the one that we are going to transform the least, then we want that one as our middle axis, so that the gimbal lock is generated there. So we need to use X, Z, Y. Okay. So let's see what happens when we animate this guy with this particular orientation. Let's open the curve editor and let's move forward in time. You know what? Let's zoom this out because it's zoomed in way too extreme. We're not going to be able to see much. There you go. Something like that. And let's try rotating X. The editor zoomed out again. There you go. X is fine. Let's try Y. Yep, Y is good. It's just moving Y. Let's try Z. This one, as you can see, only generates one curve because we have a parent aligned to the joint. But in the viewport, you can see how gimbal lock is there. But we don't really care much about this particular axis on Z. We just need to be careful about it, that's all. And since it's the axis that is going to have the least motion, at least we know we're okay. So that's pretty much order of rotations. And as I said, it's something that goes hand in hand with the joint orientation that we talked about previously. So obviously a different orientation than this one will require a different order of rotations. And it also depends on what kind of motion you are trying to give your object that you have selected. But I think you got the idea. So this has been covered. We can actually start to create some joints for our character and rigging stuff. All right, let's go to the next chapter.